Welcome to the Public Exam Review for Unit 8, Chapter 8 on logarithmic functions. In this presentation, we will convert exponential functions to logarithmic form and logarithmic form back to an exponential form. Here we will focus on expressing a logarithmic function as an exponential function and vice versa. And we will also evaluate some simple logarithms using a variety of methods. First of all, let's look at an equation in logarithmic form. We have the log of x to base c is equal to y. Note that in exponential form, you have the same base. So to write it in exponential form, we could say that c raised to the power of y is equal to x. The base of your logarithm is the same as the base to your power. So we could say c to the y is equal to x, which would be the equivalent exponential form of this logarithmic form. Both of these equations would produce the same graph. It is important to note that the base of a logarithm and the base of a power of exponential form has to be greater than 0, and the value of c cannot equal 1. As well, you cannot take the log of 0 or the log of a negative number. So it's also important to realize that this value of x has to be greater than 0. Let's look at some examples whereby we convert from exponential form to logarithmic form. We know that 4 squared is equal to 16. In logarithmic form, we would write that as the log of 16 to base 4 is equal to 2. Notice once again that the base of the logarithm is the same as the base to the power. So we say that the log of 16 to base 4 is equal to the exponent 2. In the second example, we have 5 raised to the power of a negative 2 is equal to 1 over 25. So to write that in logarithmic form, we say that the log of 1 over 25 to base 5 is equal to a negative 2. In the third example, we would write it as the log of 1 over 10,000 to base 10 is equal to a negative 4. In the third example, or in the fourth example, we would write it as the log of 1/3. Sorry, the log of 3 to base 27 is equal to the exponent 1/3. And then in the last example, we just have variables. If z is equal to x raised to the power of y, then we say that the log of z to a base of x is equal to y. I want to just look at an example here from this first one. Here you have the log with a base of 4. And note that you can write the number 16 as 4 squared. It's equal to 2. Similarly, we can write the next example, 1 over 25 with a base of 5. 1 over 25 is the same as 5 raised to the power of negative 2. And notice that the answer is a negative 2. In the third example, we can rewrite 1 over 10,000 as 10 to the power of negative 4 with a base of 10, and the answer is a negative 4. That gives us a property of logarithms that we will use frequently throughout this chapter. If you have the log of c raised to the power of k to a base of c, then the answer will equal the exponent k. That property is used frequently as we solve some simple logarithmic equations. In the next slide, we have to convert from logarithmic form to exponential form. And when I convert to exponential form, I always begin with the base. So if we have the log of 64 to base 8 is equal to 2, then we can say that 8 raised to the power of 2 is equal to 64. In the next example, we have the log of decimal 001 is equal to a negative 3. Notice here that there is no base given to the log. So this would be an example of a common logarithm that you could actually evaluate on your calculator if you wanted to. However, when there's no base given to the log, we should know that the base is a base of 10. So we write it in exponential form as 10 to the negative 3 is equal to decimal 001, which we know is equal to 1 over 1,000. In the next example, we have 2/3 is equal to the log of 4 to base 8. Again, begin with the base to your logarithm. We have 8 raised to the power of 2/3 is equal to 4. We can verify that because 8 to the power of 2/3 is the same as the cube root of 8, all squared. The cube root of 8 is equal to 2, and 2 squared is equal to 4. In the next example, we have the log of x to base y is equal to z. So converting these variables to an exponential form, the base to your log is y raised to the power of z is equal to x. And then in the last example, we have the base of 3 raised to the power of 1 is equal to x plus 2. And this is an equation that we could use to solve for x, whereby we would say 3 is equal to x plus 2, so we know that the value of x is equal to 1. So that's how you convert from exponential form to logarithmic form and vice versa. Let's look at some examples. Here we are asked as a multiple choice item, what is the exponential form of the log of a to base b is equal to c? To convert from logarithmic form to exponential form, we begin with the base. So the base to the log is b raised to the power of c is equal to a. And that answer corresponds with C as your multiple choice item. That question was on a previous public exam in another course at another time. So you can expect that you might see it on your public exam as well. In example 2, what is the value of the log of 125 to base root 5? Now this one is a little bit different. We cannot raise 125 to a power of root 5. Not easily anyway. So here's how we would approach this type of a question. What you would do here is you would let the log of 125 to base root 5, let it equal x. And now you could convert it to exponential form. So you would say the root of 5 raised to the power of x is equal to 125. In the back of my mind, I'm thinking that both sides of this equation could be written with a base of 5. The square root of 5 is the same as 5 raised to the power of a half raised to the power of x. 125 is the same as 5 cubed. On the left side, you can multiply those exponents since you have a power of a power. So we have 5 to the power of x over 2 is equal to 5 raised to the power of 3. When two powers are equal, if they have the same base, then the exponents must be equal. So now we could conclude that x over 2 is equal to 3. Cross multiplying, we get the value of x is equal to 6. Therefore, we know that the log of 125 to base root 5 is equal to 6. And this answer corresponds with C as your multiple choice item. In example 3, we are asked what is the value of x for the log of 3 to base x plus 1/3 is equal to 0. So now we are trying to solve this equation for x. So we could rewrite it as the log of 3 to base x is equal to a negative 1/3. In order to solve for x, we need to convert it to exponential form. So we have x raised to the power of a negative 1/3 is equal to 3. In order to solve for x, we need to raise both sides of this equation to the power of negative 3. What you do to one side of an equal sign, you do to the other. So in this case, in order for us to get x raised to the power of 1, we need to raise both sides of this equation to the power of a negative 3. On the left side, we'll get x equals 3 to the negative 3 is the same as 1 over 3 cubed. So the value of x here equals 1 over 27. So this answer corresponds with multiple choice A. In example 4, we are asked, what is the domain of the function defined by y plus 2 equals the log of 3x plus 1 to base 3? In this case here, we are looking for the domain of the function. You have to remember that you cannot take the log of 0 or the log of a negative number. So in considering the domain of the function, the argument here, which is denoted by 3x plus 1, has to be greater than 0. Therefore, 3x has to be greater than negative 1, and x has to be greater than a negative 1 over 3. So the domain then will be all values of x such that x is greater than a negative 1 over 3, where x belongs to the set of real numbers. It's just important to remember here that you cannot take the log of 0 or the log of a negative number. So this value, 3x plus 1, has to be greater than 0. In example 5, we are asked to solve for x. Here you have the log of x all squared minus 5 times the log of x is equal to 6. In order to solve for x here, I recommend that you let the log of x be represented by some other variable. Let's let it equal m. So then we can rewrite this as m squared minus 5m. We can bring the 6 over to the left-hand side. Minus 6 equals 0. And now we can factor that. It's in a quadratic form, which we can factor. So the factors of a negative 6 that have a sum of a negative 5 would be m minus 6 multiplied by m plus 1 to equal 0. So we have m minus 6 equals 0 when m is equal to 6. Or m plus 1 equals 0 where m is equal to a negative 1. Now those are values for m. However, we need to solve for x. So we need to replace m with the log of x. So we have the log of x is equal to 6, and we also have the log of x is equal to a negative 1. In order to solve for x, we need to convert it to exponential form. Notice here that there is no base given for your logarithm. So we know that the base here must be 10. So we have 10 raised to the power of 6 is equal to x. So then that value of x, 10 raised to the power of 6, is equal to 1 million as a final answer. In the other case, we write it as 10 raised to the power of negative 1 is equal to x. Therefore, x is equal to 1 over 10. And they would be two solutions that would satisfy this equation. In another example, we are asked to solve the log of x to base 3 all squared minus the log of x raised to the power of 4 to base 3 is equal to a negative 3. In this example, we begin by using one of our properties or the laws of logarithms. And the law of logarithms here is this. If you have the log of m raised to the power of p to base c, you can put the p in front of the log of m to base c. So this is a law of logarithms that you study in Section 8.3. So what I will do is apply that log to the 4 that's here in this equation. So that leaves us with the log of x to base 3 all squared minus the 4 can be put in front of the log of x to base 3. Bring the negative 3 to the left-hand side, so you get plus 3 is equal to 0. So now, once again, we have it in a quadratic form. So what we'll do here is we will let the log of x to base 3 equal another variable. Let's let it equal m. So now we can rewrite it as m squared minus 4m plus 3 is equal to 0. That's a form that is recognizable to us in which we can factor. The factors of a positive 3 that have a sum of a negative 4 would be m minus 3 multiplied by m minus 1 equals 0. So we have m minus 3 equals 0 when m is equal to 3. And we have m minus 1 equals 0 where m is equal to 1. Now we need to substitute in the log of x to base 3 for m. So we have the log of x to base 3 is equal to m. That's equal to 3. And in the other part, we have the log of x to base 3 is equal to 1. So in order to solve for x, we will convert it to exponential form. So we say 3 cubed is equal to x. And there we have x is equal to 27. In the second example, we have 3 raised to the power of 1 is equal to x, so x is equal to 3. And these provide us with 2 solutions for this equation. As a summary then of what we've just completed, we know that a logarithm is really an exponent. Equations in exponential form can be written in logarithmic form and vice versa. So if the exponential form is given as x equals c raised to the power of y, then we can say that the log of x to base c is equal to the exponent y. If you have any questions related to this content, please feel free to pose it in the question forum and we will be happy to answer it for you. Thank you.